Hey, everybody, and welcome to the Daily Space Weather Smash-O, coming at you here from the Smash News Network, least busted name of news. We've got all kinds of excited stuff going on today, whether it's plasma instability depicted thusly at the Western Limb, well-defined coronal holes, information about earthquakes, a guest coming on the channel on Friday night, filamentary activity, coronal mass ejections, and plenty more to cover. So first of all, note the extreme plasma instability here on the Western Limb. It looks like there could be the potential for major CMEs over in that area. The likelihood of them being directed toward Earth is dropping as those regions rotate behind the Western solar limb. Incredible filaments in the southwest, a well-defined coronal hole there as well. Some plasma reorientation happening there in the southeast. You can see a little bit of brightening happening there as some plasma splashes back down toward the chromosphere. We've got some possible new sunspots forming as well, so plenty of information to blast through today. Let's show the northeastern limb also. You can see a CME happening right there. Will it be earthly directed? We'll let you know later in the video. So stay tuned for that. There is the northwestern limb, and huge number of filaments out there. The most dense filament is this one up here, actually. Very dense filament there. We'll show you more detailed imagery of that later in the video. There's the full disk view in those wavelengths. That's 304 angstroms ionized helium plus 193 angstroms ionized iron. All right, so continuing on here, let's take a look at yesterday plus today solar intensitygram to show some growth of this sunspot. Okay, so that's significant. Also, a new sunspot spontaneously formed right here, and it's produced some significant solar flares as well. So that's a little uptick there on the Earth-facing portion of the solar disk. Also, some new smaller sunspot regions possibly forming around the eastern portion of the disk. That'll be a little bit more evident here in colorized magnetogram. Again, that is yesterday plus today, February 23rd. So continuing on here, let's take a look at volcanoes, as there is some volcano alerts here, some new volcano alerts around Alaska. So first of all, Shiveluch is exploding, producing a 15,000-foot ash plume over Kamchatka, over there at the other western side of the Pacific. Suwanosejima producing a 7,000-foot ash plume. Karengatang producing a 7,000-foot ash plume as it explodes. So we're talking about seismic distribution of quakes here underneath Trident, Nova Rupta, and Majik volcanoes. Also, Semeru is erupting. That's East Java, Indonesia, by the way. 15,000-foot ash plume from Semeru. It's a flight level 150. Dakono exploding, flight level 070. It's a 7,000-foot ash plume over Halmahera. So here we've got Aniakchak on the Alaskan Peninsula. Volcano alert was raised to yellow as a result of deep magmatic activity happening there. Although no expectations of impending and sudden eruption. Again, the alert level raised there at Aniakchak volcano on the Alaskan Peninsula. Also on the Alaskan Peninsula, Trident. That's the main culprit there for deep seismic activity. That's also raised to yellow alert level. The current period of seismic unrest is prominent in the area under Trident, but the rate of earthquakes has also increased in the region beneath Martin and Majik volcanoes. Because of the initial sequence of deep earthquakes and continued episodes of tremor under Trident, it is most likely, though not certain, that the unrest observed in the area is due to movement of magma or magmatic fluids at depth there. Popocatépetl exploding mildly. No indication on the ash plume over central Mexico. Fuego exploding, flight level 150 over Guatemala. Sangre exploding, flight level 210 over Ecuador. Revenador exploding, flight level 150 over Ecuador. From Revenador, that's a 15,000-foot ash plume, and intermittent emissions from Sabancaya also. Next, we'll look at seismicity here, and we've got a fascinating article to share with you here. First, the 90-day bar graph from volcanodiscovery.com, and we've moved into a realm of high seismic activity, mainly as a result of this 6.8 magnitude quake in Tajikistan. So there you go, near the China-Afghanistan border there. Tajikistan experiencing a 6.8. It is in a pretty hilly-looking, fairly unpopulated region, although there is at least one town certainly that felt that, and there is probably quite a bit of damage as a result of a quake that size in a place like Tajikistan. There is the location of that 6.8 magnitude quake. It came in early this morning at 0:37. And let's check the rest of the list here. We'll report on everything over a 5 magnitude. And besides that, seismic activity has been very low, folks. So remember, we say it regularly on the channel that any earthquake can be a foreshock. So let's hope that's not a foreshock to a larger quake because, well, those buildings in Tajikistan are probably not built to what we would consider modern Japanese or California-style earthquake code. So you'll see a bunch of aftershocks there, like that 5.0. And actually, that's the only quake in the past 24 hours that's over a 5 magnitude. Besides this one more here in Chile. So only 3 quakes over a 5 magnitude in the past 24 hours. And here's the article that we're talking about. Deep earthquakes reveal shocking series of secrets of the inner earth, rather. So yeah, the lower portion of the upper mantle has some properties that are evidenced by deep earthquakes that you may be interested in as a regular viewer of our channel. This article from scitechdaily.com. So imagine dipping a spoon into a jar of honey. That honey will, when you pull the spoon out of the jar, that honey will reformulate itself. Turns out the area under Fiji is in the process of doing that, and it takes years. So back in 2018, we covered an 8.2 magnitude quake at over 350 miles depth. And guess what? Fiji is now sinking. Yeah, it's sinking. I'm sorry, Tonga is sinking. Tonga is moving slowly down at a rate of 1 centimeter per year. So it's still settling from that 8.2 magnitude ultra-deep earthquake. Super interesting. If you want to read the article, it'll link to the paper as well. You can find it on scitechdaily.com, our regular Science Wire publication. Let's end on this great cutaway. And if you think you have an idea of how Earth's geomagnetic field is generated, let us know in the comments what you think. What do you think this layer is made of? What do you think this layer is made of? What do you think this layer is made of? That's the inner core, by the way. The outer core, there's the mantle, and there's the very thin crust. The main portion about the planet that we know about, as we know very little about the rest. Anyway, let's get back to space here, since it is the main purpose of the video. So here is 171 plus 131 angstroms. You may see some major brightening happening here, mainly in the eastern limb, the eastern portion of the sun. And yeah, so some flare players happening over there, including this new sunspot that rapidly formed, and this sunspot up here that's grown in the past 24 hours. And by the way, if you haven't visited the links below the video, please support the channel by visiting the links so you can save some cash on your Hemp Lucid purchases by entering the promo code SMASHOMASH. It's no longer SMASHOMASH10. The promo code is now SMASHOMASH, so we've got a new promo code. Enter that on checkout to save some cash. Use the links below the video to visit the Hemp Lucid shop if you are in the market for such things. If you want to support the channel via subscription services, consider becoming a member of the Smash Team, smashomash.com/Smash Team. And thanks for leaving comments. Mike, smashomash.com/Smash Team is the official subscription services site of the Smash News Network, least busted name in news. So join us over there. If you want to see the latest posts, we do share things besides space weather with our Smash Team members. Join at the gold or silver level if you want to support the channel. Join at the bronze level. You can still receive email alerts about disasters like tsunamis and other space weather type events. I should say space weather type events. You can find our posts page right there, links to the merch, and links to the Hemp Lucid shop right on the Smash Team page, smashomash.com/Smash Team. Today's featured product is the Galactic Federation Special Forces motto. The tagline of the Galactic Federation Special Forces is indeed Universum Liberate. If you don't know what it means, well, you probably have access to the internet, otherwise you wouldn't be seeing the videos. I'll bet you can probably figure it out. And if you don't know Latin, you can frighten your friends and foes and convince them that you're in the Illuminati by perhaps going around speaking Latin, or maybe having a t-shirt that says Universum Liberate, or what about a miniskirt? Because it's a message of freedom and liberty, folks. Yeah. If you can't bring freedom and liberty to your town, county, state, nation, hemisphere, planet, solar system, why not bring it to the galaxy? The symbolism represents the Milky Way galaxy. The key represents the signal's strength, integrity, and security. The lightning bolt represents instantaneous galactic scale reach. And this little flash up here is, well, it represents classified. Links below the video to that. You'll find our Redbubble shop there in order of best selling. Please keep in mind that the Smash News Network least busted name of news is apolitical. We are pragmatists, and we are critical of all of those in power, especially when they make terrible decisions on our behalf. So here we are, back to space. Be a hothead like me and keep your eyes on the sun. Thanks for stargazing with us once again at the Smash News Network least busted name in news. Here's 171 plus 335 angstroms. Eyes on this filament down here. This one is pretty sweet. And we've also got your classic 304 angstroms ionized helium wavelength. You will see some plasma splashing back down right here. That's a little bit of an uptick in X-ray activity as a result of plasma ending up back down toward the chromosphere. Anyway, we've seen a dip in solar activity essentially since yesterday because of a bunch of setting sunspots in the west. We've got some sunspots forming in the east to make up for that. However, the 10.7 centimeter radio flux is now down to 152 solar flux units. And there's the one-year graph to put that in context. The 10.7 centimeter radio flux is represented by this black line. Let us know how low you think it's going to go before it starts coming back. I don't think it's going to drop below 147. That's my guess. 147 is going to be the new support point for the 10.7 centimeter radio flux. And from there, it's back up. Anyway, here's the Space Weather Enthusiast dashboard. And NOAA didn't forecast any geomagnetic storms or geomagnetic unrest, but we've got a bit of a head scratcher happening here. So not exactly sure what's going on with the solar wind at the moment. We'll get to it. That's your Space Weather Enthusiast's dashboard NOAA forecast. And we had some unexpected geomagnetic storm and unrest conditions here. So first thing this morning, universal time, we did see a KP 4.67. Nearly a full-fledged G1 geomagnetic storm, nearly a KP5 there, significant geomagnetic unrest happening, but now calming down a bit. So we've got some weird solar wind parameters that we'll get to here. First, Earth's magnetic moment from space. So this is the past 4 hours. You will see some rather significant variations in magnetohydrodynamic pressure depicted here in the past 4 hours. And it's because we've got a turbulent solar wind at the moment. We've got a solar wind that's apparently pulsing, as you can see depicted in the imagery there. Next, Earth's magnetic moment from the ground. This is our Geospace Ground Magnetic Perturbations movie for the past 4 hours. And you should see those bright spots turning off and on, similar to the other depicted information. Keep in mind that's derived from the Space Weather Modeling Framework. If you want to read about that, click the Details tab on either of those pages and you'll see it. So here's what we're talking about, this head scratcher here. So this looks like a coronal hole high-speed stream, kind of, because we do see a ramping up of the plasma temperature. So this lower pane here, the green pane, we do see an uptick in the plasma temperature here, but it's very minor. And it's at the same time as this long-term uptick in the solar wind speed. As far as the solar wind density, it's oddly dropping off here. So now just keep in mind that that is measured at Lagrangian point 1. So the solar wind can't be measured from inside Earth's magnetosphere. That's why we have spacecraft at Lagrangian point 1 like the SOHO LASCO and the Discover and the ACE to measure the solar wind parameters out here about 1/93rd of the way from Earth to the Sun. And so what we're seeing here is some big variations in the solar wind density. That's sort of the main thing. Solar wind speed here looking fairly consistent, but solar wind density and plasma temperature are kind of all over the place. We do have a significant signal from the BZ also. We may stay in geomagnetic unrest conditions here, especially if we see this level of solar wind density and solar wind speed continue. So this is, again, it's a bit of a head scratcher, not exactly sure what's going on with that. It does look the most like a coronal hole high-speed stream, but what's weird is we didn't really see a good signal for density uptick or drop-off as the solar wind speed rose. Current conditions are listed as pushing 600 kilometers per second here at the moment, with an incredibly low solar wind density of 0.16 protons per cubic centimeter, one of the lowest solar wind densities we've ever reported, and that's low enough to cause the spacecraft to believe that they're reporting an error. So anyway, it's more likely that it's around 10 protons per cubic centimeter, but we'll just have to see how this resolves. And it looks like we do have the ACE and Discover there, both reporting. So again, those are located at Lagrangian point 1, well outside of Earth's magnetosphere. It's something like around 4 lunar distances, orbiting that gravitational point of Lagrange point 1. Next, we'll look at magnetic data, and here is the GOES magnetometer readout for the past 3 days of GOES 16 and GOES 18. We are seeing some sawtooth readings there. That's a characteristic of coronal hole high-speed streams. And let's take a look at the heliospheric current sheet next. And stereo B has crossed the sector boundary, and stereo B, Earth, and stereo A are all now in a South Pole-oriented current sheet. You can see that in red, North Pole current sheet depicted in green. Welcome to the South Solar Magnetic Pole. So here's our line of sight field plot. The sun's B field here depicted in blue. We do see some variations happening over there, just beyond our view there in the eastern limb. You can see the B field moving around a bit over there. That could be an indication of some sunspot activity. We'll just have to wait and see. Here's our line of sight coronal hole plot. We've got South Pole-oriented coronal holes here at the moment. Let's bring up the latest image before we show the SDO imagery. So there we've got all South Pole-oriented coronal holes, and the B field line is like this. So we've got a North Pole coronal hole over here, and all the rest of these are south. We are toying with the possibility that we may be able to forecast a little bit more about CME and coronal hole impacts based on the polarity of the coronal hole. So at the moment, we've got all South Pole-oriented coronal holes to work with here. So in a few days, we can expect a significant uptick in the solar wind parameters from this transequatorial South Pole-oriented coronal hole. And that brings us to sunspots. So let's move on to sunspots next. Again, we've got a couple new likely named groups, at least 3 likely new named sunspot groups today. One is almost 100% likely to be named, and that would be this one up here. So that has produced some flaring also, this group right here. That is the second most likely place to see large flares after this group, sunspot 3234. So this will likely be 3235. There are a couple other small pores possibly opening around here in the eastern limb. We'll keep you posted on that. And here is some SDO imagery. We've included 94 angstroms with the SDO continuum there. You see a sunspot rapidly form and start producing some significant flares also. That's this one right here. Again, that'll be likely known as 3235 will be the likely name of this sunspot. Sunspot 3235. And I don't know why this image got shifted up so high, but it is far enough south to be able to see the formation of that. It is a magnetically complex sunspot group. Also a little bit of growth with 3234. We'll show you high-res imagery of that at the end of the space weather portion of the video, at the transition between space weather and meteorology. We'll look at energetic particles and solar flares next. No relativistic particles to report on in the GOES proton flux. And we've seen a bit of an uptick here. So an uptick in X-ray flux. So I'm expecting an uptick in the radio flux coming today, as we see, again, multiple sunspots forming in the east. That is your GOES X-ray flux over the past 3 days. And we've got, counting yesterday plus today, we've got 4 M-class flaring events in the past, well, yesterday plus today. I won't say the past 24 hours, although that is what is depicted in this imagery here. So, again, you see that new sunspot group rapidly forming and not coming up short when it comes to solar flaring. It'll look great in 131 angstroms as well. So that is what's going on, folks. And we've got coronal mass ejections and plenty more in-depth space weather to cover. So this is the point in the video where we take a step back and we consider what's going on overhead. Now, we're located in Lehigh Valley, Pennsylvania. If you want to create your own star chart, just head to skyandtelescope.org. You can make one just like ours, but for your location. And if you're up before dawn, you may see Mercury and Saturn being chased by the sun across the ecliptic. And you may also see the summer triangle forming, which consists of Deneb, Vega, and Altair. Summer triangle forming overhead in the northern hemisphere. And here's what's going on in the solar system. So this is where things are located now. We'll advance this 1 week. We will have a gibbous waxing moon by the 2nd of March. How time flies when you are in an early spring. Yeah, it's a warm snap in the mid-Atlantic states, causing cyclists to do a lot more mileage than expected. All right, so here we're looking at coronal mass ejections, and we do see some. That's yesterday's imagery from George Mason University. 74 frames. And if you're wondering if those are earthly directed, well, the answer is no. No, they are not. Here are today's frames. That's only 4 more frames, so let's move on to stereo A. And, of course, the Soho-Lasco C3, which we talked about earlier, is located at Lagrangian point 1. So keep in mind these images are not synced. Stereo A on the left, Soho-Lasco C3 on the right. And it's basically just a solar light show. We'll show you some more imagery of that to show you the filaments that we're ejecting there. There will be some SDO data that might interest you here. Those CMEs are harmless and not earthly directed. Here are our custom 24-hour videos. SDO 304 angstroms plus Soho-Lasco C3 and C2. A really cool shell ejection happening there where you've got like a void in the middle of the CME. It looks like a bubble. A bunch of empty space. So yeah, again, those CMEs are harmless. They are not earthly directed. And even if they were earthly directed, they would be largely harmless. Don't believe the hype. The reason that we're hoping for auroras on the channel is because we want to see the auroras and film them in Lehigh Valley, Pennsylvania. Next, we'll look at filaments. Again, this one up here in the northwest is shockingly dense. You can see how much absorption that's causing. That's why it appears dark, because it's not sending a lot of 6,562.8 angstroms wavelength radiation. That's hydrogen alpha, by the way. That's the vibrations of the hydrogen. And yeah, that's huge number of filaments here, huge filaments and a huge number. So this huge snaky filament here, that could use a name for sure. That one's actually getting denser, it looks like. Keep in mind it is just to the southwest of this new group. So yeah, it's a good time to name filaments at the moment here. There are some great filaments to name. And if you'd like to do that, join us on Twitter. Yeah, at Smashomash. Just follow that hashtag, name that filament. And space weather, of course. Don't forget to name filaments after living people. You've got to do it on our Twitter feed. Just tag us on Twitter or whatever, and we will retweet whatever you state. Let's play that one more time. And invite all of our viewers to join us on Twitter and name that or those filaments. There's also a new link for the free mushroom gummies. So that is now pinned on the Twitter feed as well. There is shipping for the free mushroom gummies, but you can get your samples anyway. So see our pinned tweet on that. Still giving away free mushroom gummies while supplies last. So if you'd like to try some samples of the mushroom gummies, feel free. Again, you'll find the link on the Twitter page, twitter.com/smashomash. So try those out if you haven't. And let's get back to space here as we've got the last 24 hours in SDO 171 angstroms. Again, you can see the great plasma bridging happening here at the equator. 171 angstroms is a great wavelength to view that. And there still is a significant likelihood of seeing a major flare actually from this area here. Because if that plasma suddenly collapses or reorients, a lot of fast-moving particles will have to take different routes, and that is part of what a solar flare is. That causes radiation to be emitted. And let's look at the past couple of hours here from the GOES 16 SUVI, as we keep you current on what's going on in space. And to quote Run DMC, we always tell the truth, and then we never slip no lies in. So here's the past couple of hours there. The GOES 16 SUVI with its great wide field of view. You see all this unstable-looking plasma all around the western limb. And plenty of unstable plasma right in the center of the solar disk. So if this filament right here ejects, that is much more likely to be earthly directed than any other filaments. And again, that one could use a name, so join us on Twitter if you want to name that. If not, good luck. Let us know what your favorite social media is in the comments. And let's move to bonus features. So we've got satellite charging hazards here, minor surface satellite charging hazards there on the Central Pacific Ocean. Low energy electrons there are building up on the surfaces of satellites. Let's see what's going on with the GOES electron flux. That looks a bit like a coronal hole high-speed stream as we see a very low GOES electron flux. Keep in mind we're near midnight local time for the satellites. That's what these M's denote. So we'll have to keep an eye on what's going on with that. And when I say ion, pardon the pun. Here's the forecast model for relativistic electrons by NOAA. They're expecting an uptick there, and based on what I see, I'm expecting flat to lower levels. We'll have to see what happens to the forecast on tomorrow's Daily Space Weather video. And there's the one-year chart to put it in context. Since it looks like a coronal hole high-speed stream, I would expect this to come down a little bit, but no major change. Next, the F layer of the ionosphere, which is where the GOES 16 and GOES 18 measure the electron flux. Feel free to pause the video on this frame if you aren't familiar with thermospheric temperatures, radiation penetration, and molecular concentration. Here's the vibrational frequency of the ionosphere. That is one slice, the F flare, which is at about 300 kilometers of altitude. We certainly see some low frequency anomalies there. Wow, some major low frequency anomalies around the South Atlantic anomaly. Let's bring up the latest image here. There's the anomalygram, by the way. That's the anomaly in megahertz from a 30-day median. Huge low frequency anomaly happening down here in around the 30 degrees south latitude line, stretching all the way down to the South Pole, really. And also some low frequency anomaly signals here around India, Southeast Asia, and the Middle East. Anyway, let's bring up the latest image here. There is 1230 universal time ionogram and 1230 universal time anomalygram. We'll also show the total electron content forecast, which shows the free electrons between your GPS satellite and your handset. It's a run of about 12,500 miles. Those red areas are the most likely places to see GPS errors. If you are in a location where you have to navigate using your GPS, perhaps use your Wi-Fi location accuracy. That does help if there are Wi-Fi hotspots around where you are navigating. If not, you may see some significant GPS errors there. I've got pretty anomalous total electron contents here. Again, that's the free electrons from the inner portion of the outer Van Allen belt at about 12,500 miles all the way down to your GPS handset. Last but not least, for space weather, we will cover the latest intensitygram and latest solar magnetogram. So here we go. Do we have a new sunspot rising up here? Well, no, but we have a new sunspot formed right there. So we've got this one. That's definitely going to get a name. That's 3235. And this one might be known as 3236. Also a new sunspot down there. That'll likely get named. So at least 3 likely named sunspot groups at the moment as it stands. There's your rock back to the magnetogram. And before we transition to meteorology, please take a moment to press like, subscribe, share, etc. Click our links if you're unwilling or unable to support the channel via Smash Team memberships at the gold or silver level. Hit us up on social media. Help us out with clicks. Tell us what your favorite social media is in the comments, or perhaps share our videos on your favorite social media account. We want to know what you're up to online, so let us know what you think. Smashomash.com, and welcome to the Neo Renaissance. It is the most detailed space weather in the world and most comprehensive imagery of the sun you'll find in the known universe. So press like, press subscribe, press share. We're pushing 6 years on our daily space weather videos. Check our playlists for other content not related to space weather, such as our chemical castration live streaming series. Guess what? On Friday, that's tomorrow night, we're having Scott McIntosh. We're going to have a brief video discussion with Scott, Deputy Director of NCAR, which is the National Center for Atmospheric Research. He also works for UCAR, the University Corporation for Atmospheric Research. And why? Because, well, Scott has done some forecasting, which came up to be correct. So, nothing like a grand solar minimum. It's the termination event. If you haven't read about it, he was writing about it back on, well, Dr. Tony Phillips was writing about it on June 10th, 2021. And it turns out that there seems to be some information that a lot of people aren't familiar with. The Terminator event. So we're going to have some heretical information about that coming on Friday, as some people forecasted a much stronger solar cycle for solar cycle 25. Shout out to Scott McIntosh. Expect to see a video go up Friday night, a rare Friday night video upload following our recorded video call. Next, we're looking at sea surface temperature anomalies and ocean currents to show you the Gulf Stream, which is alive and well. It's still heating up Ireland and Iceland, and frankly, all of the Northern Hemisphere. let's move around and show sea surface temperature anomalies. And guess what? They're breaking up here around the equatorial Pacific. So it looks like La Nina is ending. Most likely, we're seeing evidence of it right here, as we're seeing huge breaks in this anomalously cold water around the equatorial Pacific. You can see the current is shifting around here. The water is getting warmer at the surface, and that looks like an end to La Nina, as many competent meteorologists forecasted. Anyway, these are the rest of your ocean surface temperature anomalies. New Zealand, you're in hot water, quite literally. Southern Ocean here, surrounded by largely anomalous hot water, except the part where it meets the Pacific. Anyway, there's Earth's largest surface heat sink. Why? Because water has a really high heat latency, folks. Anyway, here are the jet streams of the eastern world. Like sands through the hourglass of time, these are the jet streams of your lives. Here are the surface winds of the eastern part of the world. Surface winds of the western world, depicted thusly. Jet streams, shown here. Jet streams of the central world, like Europe, Africa, and the Middle East, shown here. And surface winds shown here. All right, let's get to some forecasts. First, we'll show the clouds and fog over the Americas real quick. Some turbulent weather down there in the southern Pacific. Anyway, that's clouds and fog over the Americas using the NASA GOES Interactive Weather Satellite 3.9 nanometer shortwave radiation. That's part of the infrared spectrum. Next, our weather.gov map. We've got blizzard warnings continuing here. In the north central U.S., we'll scroll down to show you the key briefly. If your county or location is lit, click your county or location. Those are too many counties to go over. Here are some forecasts. Starting out with temperature anomaly. So there's your GFS temperature anomaly forecast based on it's the GFS temperature anomaly forecast in degrees Celsius. Expecting some shockingly warm temperatures in Pennsylvania today. The forecast is for like 65 degrees Fahrenheit for a forecast high today, as we've got some intrusively cold temperatures here, which will subside in the next 3 days in the north central U.S. Here is our pressure and precipitation forecast based on the same GFS 72-hour model. That's pressure and precipitation, and yowzers, California is getting inundated once again. Heavy storms and heavy snows, likely wet snows. If you are living in California without a generator, that is berserk. Continuing on, our 72-hour GFS accumulated positive snow depth change in inches, and check it out, they're forecasting like pushing 4 feet of snow there in portions of California. Positive accumulated snow depth change in inches will also show that's the GFS model, will also show the Euro model. So that's the next 3 days GFS. There are the next 3 days GFS in new snow on windy.com. And there is the Euro model. Again, GFS, Euro model, GFS, Euro model. Let's continue on to our lightning mapper. Do we have any terrestrial lightning in the U.S. at the moment? I don't think so. There's a real-time lightning map from lightningmaps.org. And we'll close out with Doppler radar, clouds and fog, and water vapor. So there's a U.S. Doppler radar map showing all 50 states of the former nation, now Banana Republic. There is the lower 48. There is the clouds and fog scenario. And there is the water vapor. We've got dry air aloft over Pennsylvania. The sun's going to come out. The fog and clouds are going to burn off, and it's going to be one heck of a day in the mid-Atlantic states. Here's your recap. U.S. Doppler radar showing vertical motion of water droplets and ice crystals in the air column. Satellite-based systems showing the 3.9 nanometer infrared radiation emissions from clouds and fog. And that is water vapor. We've got dry air stretching all the way from New York to Baja California, a string of dry air there. And thanks for viewing the Daily Space Weather video and for viewing the Smash News Network Least Busted Name in News. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off, and may that solar wind be at your back.